We've talked about kind of representing everything algebraically, but now I want to talk about representing positions, velocities, accelerations, and all this kinematic stuff using graphs. So if you create a position versus time graph, so let's just kind of write that out. We've got time and we've got position. It's a little wonky, so I'll rewrite it there. So say we've got some graph that's like this. Now we know from algebra or from previous math classes that I can calculate the slope of this graph. The slope is just going to be equal to change in x divided by change in t, right? Rise over run. But we've also seen that delta x over delta t is the same thing as v bar. So if we have a graph of position versus time, the slope tells us velocity. So if you can find the slope from a graph of position versus time, you know the velocity at that point in time. Let's look at a velocity versus time. Similarly, if I have a velocity here, we can also calculate the slope of this graph, and that will be delta v over delta t, which, similar to before, will tell us the average acceleration. What's also interesting is if you look at, say, an area, say just from t1 to t2, you can calculate this area by multiplying it and getting v1 times t2 minus t1, which can also be written as v times delta t, which is equal to delta x. So in other words, we've got the slope tells the average acceleration, the area under the curve tells the change in position, the displacement. This also works with negatives. You just have to realize that that would be a negative area. Then finally, acceleration versus time. You might have some guesses as to how this would work. I would challenge you maybe to pause and take a second to think, what would the slope mean, if anything? What would the area mean, if anything? So in this case, the slope doesn't mean anything because we haven't talked about anything that is change in A divided by change in T. But if we do the same thing we did before, label this A1, T1, T2, A1 times T2 minus T1 is equal to A1 times delta T, which is also equal to change in velocity. So the area under the curve is delta V. So this is just kind of useful to think through and be aware of. We'll play around with it. It comes up in things, but thinking about things both graphically and algebraically is often useful in physics.